Okay, question 6. So it says use the figure below to answer the following questions. Assume X is the centroid. Centroids deal with medians, okay? And what we know with centroids, we have those fractions of 2/3 and 1/3, okay, depending on which segment we're looking at. All right. Now I'm just going to fill in some information here. We're dealing with medians. Medians deal with midpoints. So that means that S is a midpoint. It means that R is a midpoint. And it means that Q is a midpoint. Okay. So we're given on letter A that XB is 20. Okay. And we're trying to find XS. So what we need to recognize is that XB to XS, so the long segment to the short segment, all right, is a 2-to-1 ratio, which means that this XB has to be double the size of XS. So to find XS, we just cut XB in half, which means that XS is 10. Okay? Now, not always going to be that easy. All right. So if you look at B, this time you're given that XB, all right, which is 4X plus 10, but you're given the entire segment of SB. And so when you're given the entire segment, this is when you have to use those fractions of 2/3 and 1/3. Okay. So on this one, all right, I'm given XB, which is the long segment. All right, long segment, I use 2/3, okay? But I use that 2/3 with that entire segment. So I'm going to do 2/3 times that entire segment of 5X plus 20. And that's going to be equal to 4X plus 10. And so then however you deal with fractions, you can do that. All right. I like to not have to deal with them at all. So I'm going to multiply by 3 on this side to cancel out the 3 here. But I also have to multiply by 3 here. So you're going to distribute through, all right, 10x plus 40 is equal to 12x plus 30. Okay. I'm going to get my x's on this side. So 2x is equal to 10, which means that x is equal to 5. Okay. To find SB, you can plug back in. All right, on your own. Now, our next one is dealing with AQ and QB. So if you already look at my picture, I recognize that Q has to be the midpoint because I'm dealing with medians, okay? And so I'm given AQ and QB, which means I can just set these two equal to one another. So 4x plus 6 is equal to 2x plus 20. All right, so solving, you get 2x is equal to 14, which means that x is equal to 7. Okay. 7, 8, 9, and 10, all right, are just applications of vocab once again, okay? So number 7 says the centroid is always, sometimes, or never inside the triangle. We discovered that this is always, okay? 8, the orthocenter is always, sometimes, or never on the outside of a triangle. This is sometimes, all right? What we found is that with acute triangles, it'll be on the inside. All right, with obtuse, it'll be on the outside, but with right, it's actually going to be a vertex, okay? All right, number 9, the altitude is always, sometimes, or never the side of a triangle. This is also sometimes, okay? And this is sometimes whenever it's a right triangle. Now, the last one, it says the centroid is always, sometimes, or never equidistant from the vertices, okay? So here's the thing, is when we're talking about equidistant from the vertices, all right, what that normally makes us think of is perpendicular bisectors, all right? And the point of concurrency with perpendicular bisectors is the circumcenter. But when you're dealing with equilateral triangles, all right, what's really cool about equilateral triangles is that all of the points of concurrencies, all right, for all these special segments are the same, all right? So this is only true whenever you're dealing with an equilateral triangle, all right? So this is sometimes true. So for equilateral triangles, all right, all of the medians, angle bisectors, perpendicular bisectors, and altitudes are actually the same exact segment, which means that their point of concurrencies are also the same segment, which means that the properties of those point of concurrencies are true for all of them. Okay?